Hi everybody, this video is going to cover section 6.2 and we're just going to do one page of this because there's a lot to talk about in this one page. Next video we'll talk about the next page. So first of all, we are talking about multiplying and dividing rational expressions. Rational expressions basically means fractions. Rational expressions is a quotient of two polynomial expressions. And we talk about quotient that is often expressed as a fraction. So we basically just have really complicated fractions here. Here are some examples of what we might see. And we're not going to simplify all of these right now, but I do want to tell you some things that cannot be simplified, just so you know. You can't cancel those x's together. You cannot. This is actually as simplified as it gets. Cannot go any further. Same thing here, like this 10 and this 6. Nope, you cannot simplify those. So we're going to talk about how to simplify it. Why am I saying you can't simplify those? Well, the reason is because the only way we simplify is by using common factors. And these up here were not common factors. Remember, factors means multiplying. So you can only divide out if you are multiplying. If you're adding and subtracting, cannot do it. Okay, well, if you can't just cancel like that, then how are you supposed to do it? Well, the main thing is factoring. So I have a couple of notes over here. Domain, all real numbers. We're going to talk about that after we go through the examples, but this is really, really important. Do not cancel with adding and subtracting. You have to subtract first. You have to factor first. That's the most important part of what we're going to learn this whole unit. That's really the most important thing. These two we will get to in a minute. All right, let's talk about, well, how do we do this then? Well, we factor. Remember, factor means it's involving multiplying. It's like what multiplied to get to this other thing, right? So when we think about these numbers, first of all, some people don't understand 16 is separate from x to the 11th, and 8 is separate from x to the second. So we have to simplify each piece. So can we factor this? Well, yeah, 16 is like 2 times 8, right? So that means the 8s can simplify down to 1. All right, so the first part of this is just a 2. Then the second power and the 11th power, yes, we learned that before in our last lesson, that 2 and 11 can simplify down to x to the 9th. So this one is 2x to the 9th. We're going to talk about domain in just a minute. Okay, well, that was easy to multiply. I know 2 times 8 is 16, and so that was easy to do. This one, though, how do I multiply this? Well, because this is really talking about simplifying, we have to factor it. That means I'm wondering, does this go into this expression? What do you mean, does it go in? Do I have to do long division? No, you could, but you don't have to. What you could just do is kind of do some factoring with it and see if it does actually factor out. And when we talk about factoring, we do a C method, we do guess and check method. On this one, I think this is simple enough that I can do guess and check because I'm guessing basically that this goes in, and if it does, an x has to go here, and a 1 has to go here, and it has to be a -1. Now I'm going to do my check part. My check part is, okay, that's 3x squared. The next one is a -3x. The next one is a +4x, and then -4. If I simplify this, I get 3x squared plus x minus 4. That's what that was. In other words, I did it correctly. I factored it correctly. So this is the factored version. So I no longer have this. I have this instead. And look, these are the same thing. So they factor down. They simplify out to 1. So this answer is 1 over x minus 1. It's really important that you don't forget about that 1 because they do simplify to 1. All right, this next one looks a little bit more complicated. Maybe we need to talk about AC method because, wow, that's a lot, right? And this one had like already factored out kind of, and this one doesn't. So the AC method says, all right, we're looking at 6 times 2. 6 times 2 is 12, and we want to add up to 7. That's 3 and 4. So we have 6x squared plus 3x plus 4x plus 2. I'm just doing AC method now. So I group these together. I'm going to take out a 3x and I get a 2x plus 1. That's a 4. So I'm going to factor out a 2. And when I do that, I get 2x plus 1 again. So I get 3x plus 2 times 2x plus 1. This expression factors out to this. So I'm done with this one. I did AC method and I got this. Okay, so now the question is, do either one of those go into this one? We might have to do AC again. I'm just going to go ahead and do AC method. So AC method again says, I'm going to come over here. All right, I did AC method real quick and I got this. So I'm going to cross this one out. And what I really have now is 2x minus 3 and 3x plus 2. Then I look to see which ones can be factored out, which ones cancel each other out. I'm going to erase my AC method here. In other words, I'm looking for which things, like if I put them over each other, equal 1. So 3x plus 2 over 3x plus 2 equals 1. So I can factor that out. So now what I have on the numerator, I have 2x plus 1, and on the denominator, I have 2x minus 3. Okay, so you can see a couple things. Factoring is important. We spent a lot of time on that, but we will continue because you have to know how to factor. On these, I would say if you can do guess and check factoring is going to make it way easier for you. So do that if you can. And then finally, we still need to talk about domain. We haven't done that yet. We will come back to these and talk about domain in just a minute. Okay, let's look at this next one. Well, this one's again an easier one. 10 and 6, well, 2 goes into 6 3 times, 2 goes into 10 5 times. And x to the 4th and x to the 8th, we subtract those and get a 4 on the top. So our answer is 5x to the 4th over 3. Last one, we need to do factoring. Take a second to factor this. All right, when you factor this, you get these factors. X minus 1 and x minus 1 simplify to 1. Anything times 1 is just itself, so we are left with x plus 2 over x plus 3. Okay, let's talk about domain. Domain means where the expression is not defined or does not exist. Does not exist. And capital R, it's actually like a 2-line R, kind of like the paragraph P that you do, right? That means all real numbers. Okay, so these two things you have to know about. Domain, where it does not exist. In other words, on this first one, of all the numbers I could plug in, what number would give me an undefined answer? What does undefined mean? Well, remember that anything over 0 is undefined, right? So anytime I have a 0 in the denominator, I have undefined. So if I have a 0 in this denominator, it is undefined. Well, what number would make that 0? Well, 0 would. 8 times 0 is 0. So in other words, this problem, the domain is all real numbers except 0. In other words, I can plug in any number I want to into that x, but not 0. Why not 0? Because if I had 0 in the denominator, it would make it undefined. So that means it does not exist. It is undefined there. Okay, I know this is hard. Let's look at the next one. Again, the domain here, what we do is we basically start with all real numbers except. That's what we always do. We always say the domain is all real numbers except. Well, okay, except what? Well, for one, if I get this equal to 0, that would be 1. And I can't have a 1 there because that would make it 0 in the denominator. But also back here, I had this one there before. Now I canceled it out, but still, I can't have it be negative 4/3. Where did I get negative 4/3 from? Well, I set this equal to 0, and I solved it, and I got negative 4/3. So the domain here is all real numbers except 1 and negative 4/3. On this one, the domain is all real numbers except, well, let's look at the denominator. 3 over 2. Can't be 3 over 2, because if it was, that would be 0, and that would be undefined. Well, what else? What about the one we canceled out before? We need to include that as well. So negative 2/3 is the other one that the domain cannot be. This one, easy. All real numbers except 0. It's just a 0. Okay, this one, all real numbers except negative 3 and positive 1. All right? So that's what we mean when we talk about domain, is where can it not be? In other words, where would it be undefined? What would be the 0 in the denominator? We have to think about that. Okay, in this next concept, and this is going to be the last section that we do for this video, in this next concept, there's a lot of negatives that we have to take into account. Before we even get to these examples, let's take a look at what I've done over here. If I have an expression 7 minus x. You see that that's out of order, right? The standard form would be for the x to come first. So if I rewrite it into standard form, I get this, negative x plus 7, plus because the 7 was positive. But typically we don't like to have that negative in front of a factor. And so I'm going to factor out a negative 1. If I factor out a negative 1, I get x minus 7. So if I just bring this down, I can say, well, 7 minus x is equal to negative 1 times x minus 7. They're kind of opposites from each other in a way. In other words, if I had 7 minus x over x minus 7, well, they don't cancel out to be 1, but they do simplify down to be negative 1. Okay, so that's something we need to know about. Because let's take a look at this first example. Do you see, first of all, it's out of order, so let's go ahead and rewrite it in the right order. This is going to be negative 2x plus 10. Okay, then I want to take out a negative 2 because I want to factor this down. That's what we do when we cancel these fractions. We have to factor it down. So I'm going to have a negative 2 on the outside, and then x minus 5, because a negative plus a negative is a positive. And so now these simplify down to 1. And so negative 2 is the final answer here. What's the domain? You should think about domain. The domain is all real numbers except for 5. Why not 5? Well, because 5 would make it 0. I can't have a 0 in my denominator. All right, let's look at the next one. Definitely some factoring needs to happen, right? And again, I'm going to say if you can do guess and check factoring, that is going to make your life a little bit easier. All right, let's look at the numerator first. I'm going to factor out a negative x out of my numerator. That leaves me with an x minus 3. Okay, that's kind of a hint. Because now I want to know, does x minus 3, is it going to cancel with anything? In other words, could x minus 3 go into that? I could do synthetic division, but I don't really feel like it. I just want to do factoring. So I'm going to see, is x minus 3 a factor? And so I'm going to do a little bit of guess and check. Okay, I'm going to try x minus 3 because that one would match. All right, x, I must need a 2x here, right? Because there's no other way to get to 2x squared. And this is a minus 3, and I want a plus 3, so maybe a minus 1 would go back here. That's my guess. Here's my check. My check is 2x squared minus x minus 6x plus 3. That's 2x squared minus 7x plus 3. That's what I had before. I did it right. So this is the correct factored version. X minus 3 over x minus 3 simplifies to 1. So this final answer is negative x over 2x minus 1. What's the domain? Domain is all real numbers except for 3. Even though it was canceled out, we still have to think about it. And a positive 1/2. One last example. All right, it's out of order. I need to rewrite it in the right order. I look at it, I need to factor something. In my numerator, I want to take out a negative x. In my denominator, I'm wondering, since that's an x minus 4, maybe x minus 4 comes down here too. So I factor this, and indeed it is x minus 4 and x plus 2. So my minus 4's cancel. My final answer is a negative x over x plus 2. Now you may be wondering, maybe can I cancel those x's? No, why not? Because they're adding and subtracting, they're not factors. Last thing is domain. The domain is all real numbers except, well, I only look at my denominator and I have an x minus 4 and an x plus 2. So those are my exceptions. All right, I know that's a lot to take in. We will talk about the back page next time.